I'm Richard Mans, head of DevRel at the IOTA Foundation. Welcome everyone to this sort of live stream workshop. I'm going to hand over to Andrew.
Awesome. Sweet. You're making these RPC calls. So essentially that can be a big blocker for developers if they're building out analytics dashboards where real-time data and accurate information is very important. Or if you're building out an application where, maybe you've got a front end that is dependent on on-chain events, you're going to want that app to be snappy and fast, kind of like in Web 2. So it's really important to have efficient on-chain data. So indexing is essentially a solution that is alternative to RPC calls, and it is a lot more efficient. So just to kind of compare and contrast, the difference between making an RPC call versus indexing. So when you want to do, simple lookups with an RPC, that's going to just be very basic and it's not going to allow you to be as custom. Whereas with indexing, you can actually craft some pretty complex queries to get really, really fine-tuned in the data that you're looking for. Performance-wise, RPCs, they're often going to be rate limited. They're very slow. Indexing is very fast, and they're essentially these data structures that are optimized to be queried. So it's pretty much built out for the specific use case of needing to find the information you need quickly. And as far as developer effort, RPCs, you might have to deploy a lot of different RPC calls because one call might not be able to give you everything you need. You're going to have to do a lot of different calls to get all the information you need. Whereas with indexing, you can kind of query it all in one spot, and it's just much easier to deploy, much less maintenance, a lot less headache, and just much more reliable. And when it comes to scalability, if your app is going to have a lot of people building on it, if you're going to be doing a lot of really, high transaction kind of activity, then the scalability of RPCs is very poor versus indexing. It's kind of designed for that. Decoding as well, decoding events, right? Basically kind of better understanding what you're looking at on chain. Those are some manual things you have to do with RPC calls rather than in indexing. It just automatically done for you. So, when you're trying to aggregate data, put together a lot of information, really just get, a specific insight or even a bird's eye view, it's really difficult to kind of combine and put all the pieces together in RPC, whereas with indexing, it's made really easy. So the main first way that we're going to be talking about indexing is through a product called Subgraphs. So basically the way that it works, kind of try to break it down into 4 easy steps so that we can digest, what exactly is a subgraph. So a subgraph is an indexer where it's basically an indexer that Goldsky maintains and you're going to use when you deploy on Subgraphs or deploy on Goldsky. And essentially what it does is the indexer will scrape the network to basically really efficiently and continuously get you that on-chain data so that you can basically abstract away, the difficulties of reading on-chain data directly with an RPC call, and looking on-chain is just, it's slower, as we discussed in the previous slide. So basically a subgraph will abstract away the complexities of reading on-chain data. It just scrapes that for you, and it structures it in the second step, into this much more readable and usable data structure. So it's basically what's called entities. And these are ways where you can read, on-chain events, transfers, mints, any kind of activity that's happening on chain. It gets organized into this structure that really breaks it down for you so you can have a really solid and simple understanding of the data that you're looking at. And this is stored in an off-chain database hosted by Goldsky. And so it's an API endpoint that you just basically query, right? So you're going to have this GraphQL endpoint, and you can plug that into your app, whether it's for your dashboard or your front end or your back end, and you would just query it via GraphQL endpoints. And there's a lot of really cool features that I'll touch on once you've deployed a subgraph of how you can optimize your workflow. But essentially, subgraphs come in and they replace doing simple RPC calls by having an indexer essentially scrape all the on-chain information you need, get very specific and custom about what kind of data you need, and it surfaces this data in a very efficient and optimized way for you to then query it. So subgraphs are very, very cool, and I want to show you how you can deploy a subgraph. It's super easy, and we're going to hop into the Goldsky app. And if you have not yet created a Goldsky account, if you go to app.goldsky.com, you can sign in you can just sign in with Google. So you can just, really easy flow. You could just create an account in a matter of seconds. You can follow along with this demo. So basically you just want to go to the Subgraph tab. And the first step, of course, is you want to think about what do you even want to index, right? So for this example, what I wanted to do is index the Stargate Bridge USDT on IOTA EVM. I figured that, this is just a very simple use case. It's easy to understand. We're going to wanting to be tracking the transfers of the stablecoins. So stablecoins are, of course, a very popular narrative right now. USDT is a big player in that game. And so this is just a reliable contract. This is a good example to kind of showcase, reading on-chain data. And so first things first, you're going to go to the Subgraphs tab and hit New Subgraph. And this pop-up is going to come up and it's going to show you, the steps that are required to basically deploy the subgraph. Now, we also have a Goldsky CLI. I'm not going to touch too much on that today because I'm just going to focus on the web app interface. But if you wanted to build in the terminal, there is a Goldsky CLI you can leverage. And it's super simple too. I know a lot of developers have like their own familiar flow and they prefer to do the more, coding route. So definitely can also do this in the CLI. But, with the web app, it's just a very simple, easy, basically instant solution you can spin up in minutes, right? So, of course, if you're going to be doing some extremely complex queries and you really want to make some advanced deployments, you might be better off using the CLI. But for just basic subgraphs and if you just want to learn and get started, this is super easy. This is instant, and it kind of walks you through how to do that. So I'm going to name this IOTA Demo USDT. And as you can see here in the background, I did create a subgraph yesterday. I just wanted to have one that's already deployed and, finished indexing so that we can use that as an example later. Because once this deploys, you'll see it takes some time for a subgraph to basically go through and, index everything. Of course, depending on how much data you're looking at. If you're just looking at data from the last hour, that'll be fast. But if you're trying to look at historical data for the entire contract, that can take quite a decent amount of time to index it just because of the vast amount of data. But for this example, we're going to call it IOTA Demo USDT. Now we're going to go back to the Explorer and grab the contract address. So this is the token page. You'll want to begin by clicking into the contract page to get the contract details. So we're going to go ahead, copy that, get the contract, drop it into here. Now for network, we're going to go IOTA EVM, because of course that is where the contract is on. Now for start block, depending on where you want to start indexing from, whether it's the very beginning of the contract or something more recent, you just want to put in a block number so that you can get more granular about the data that you want. But here it's showing the last balance update is on this block. I don't want to index the entire contract because that'll be pretty large. So we're just going to go ahead and index a few blocks back. So I'm going to change this number. Let's change that to like 2. So it's pretty recent, but it's not super recent, and it's also not very, very far back. So this is, just for this example, fairly on the recent end. So you got the name, contract address, network, start block. Now the final piece of the puzzle is the contract ABI, which is very important. So most contract pages, if not all of them, will have the ABI. You just go to the contract tab, and then you will go to the ABI here. Now, one thing, by the way, I just wanted to point out, just as a call out, it's critical to make sure you're looking at the source code of the contract, right? So here it says contract source code verified. Oftentimes, if, for example, I believe, looking at the USDC contract for the one here that Stargate has bridged in. So sometimes there will be a contract where it's a proxy. So you'll want to go into the original contract. So it's not the proxy. But for this one, this is the source code. So that's just a side note. So if it does say it's a proxy, you'll want to index the original contract. But for here, this is the contract source code. It's verified. So we're going to take this contract ABI, copy that. Now, before we paste it over, I just want to a little bit, review what exactly is an ABI. I think a good way of thinking about it is it's basically like a blueprint that gives instructions to the subgraph on what kind of data to map out and how to map it out, right? So here it talks about the address, the minter, you know, let's see what else we've got. Event, minter added, minter removed, right? Ownership transferred. So basically, as you can see, there's all these different names and types of events. And I will show you once the subgraph is deployed, how that is relevant and where it comes in handy. So we'll copy the ABI, drop it into here, deploy the subgraph, give that a second. Alrighty. So this is the subgraph deployment page. So anytime you deploy a subgraph, you're going to have this page, and it's going to show you all these different, metrics about the subgraph that you can rely on to basically, build out whatever you need to build out. Because it's still indexing, it might take time for all this information to fill out. So I'm going to actually go back into my subgraphs page and open up the USDT demo or the USDT subgraph that I deployed yesterday, which is currently live, and it is the same contract. It's just already indexed because I let it index overnight. So I just wanted to show you same contract, basically same subgraph, but this is just fully indexed so that we can have more data to kind of look at. So once the subgraph has finished indexing, it's going to show you that it's live from the initial block to the current block. Now, there's a few metrics that you'll want to take a look at, and they'll give you good insights into the subgraph. So entities count, that's essentially all the different events, logs, traces, right? Like everything you're looking at, entities is going to be basically the total amount of data that your subgraph is querying, right? So here we got 232,000 total entities. Now I'm going to scroll down here and expand entities because that will give you good insights into what exactly is the data that we're indexing, right? So here there's approval, initialized, minter added, minter removed, transfer. This is showing us, the count of how many entities, how many times these events occurred in the block periods that we chose. Now, if we just go back here to the ABI, remember how we were taking a look and it says, transfer, ownership transferred, mint removed. That's all this stuff here. So this is basically the entities are events mapped out by the ABI so that, you can kind of have a more readable understanding of what's happening on chain. So for this smart contract, primarily in the block periods that we chose, most of the events that are happening are transfers. And I mean, that makes sense. This is USDC. Most of the time it's just going to be moving around either between addresses to maybe they're putting it in some kind of, vault, or they're moving it across their different accounts, or they're sending it to somebody, right? It's just being transferred. So that's just what entities are. Essentially, they are the amount of events that are being indexed. Now, the rest of the data here, for example, API requests, this is just helpful for you to understand, what is the amount of times that I'm calling this API. So for each subgraph, you're going to have a public GraphQL link. And if you click this link, you'll see here this little page, right? You have this folder here. You can expand this Explorer that shows you all the different entities and all the different data points and parameters within the entities that you can query. So as an example, we're going to query some transfers. The first 100, ascending direction ordered by ID. So I went from timestamp to value. Maybe we can throw in block number as well. So when we hit that, you're going to see all this data that's going to appear, and it's going to show it in the, type of format that we selected for this query. Now, when I do call this API, that's when this is going to go up. So just now I made this call, so that went up. So this is just helpful to know, for my web page, for my app, for my dashboard, how often is this API called? What's the latency? What's the handler time, handler count, right? So this is all just very helpful metrics as you're tracking your subgraph data. Now, a couple features that are really, really useful and make your lives a lot easier when you're developing are tags and webhooks. Now, tags, basically you can think of this as a way to streamline any kind of version changes or updates you're doing on your end. So we're going to go ahead and create a tag. We'll call this prod for production, right? So basically what this does is it creates a new public GraphQL link that you can refer to. But the difference this time is, as you can see here in the URL, this says prod, versus in the previous link we had, it says the version number, right? This is useful, especially if, let's say you have an API endpoint you're calling, this API endpoint, you plug it into your app, and maybe you're having it called in various different spots. Maybe one spot is the front end, the back end, different parts in your pages. You've got the same API being called. But then let's say you decide, okay, I realized I want to be more custom about what I'm querying. I want to make a new version, deploy the same subgraph, but make a few changes to it. Then there would be a second version, right? Instead of 1.0.0, it's version 2.0.0. So without tags, you would then have to go through every part in your app where the endpoint is referenced and update that. Very annoying, very small little thing, but it's time consuming. So instead, with this prod tag, you just have to label in your app wherever you call that API endpoint, use the prod tag, right? And then anytime you update it, you never have to change it again in your app because it's just going to be referencing this prod tag. So this is just a really efficient way to just streamline that developer experience for you as you are updating and making new tags or making new versions. So you don't have to continuously change it in your backend. And last but not least is there are webhooks. So if you wanted to create, for example, maybe some kind of notification in your app, or you want something to be triggered in your dashboard or in your backend based on on-chain events, you can create a webhook, and that way, anytime that on-chain events happen, it'll automatically trigger that webhook. So this is a very, very cool feature that unlocks a lot of unique use cases, and definitely one that we're seeing used a lot. So to kind of recap, subgraphs, you're pulling on-chain data. You can query them. You can customize it. You've got these public GraphQL links. You can also create a private one if that's something that's important to you. And then you've got tags and webhooks to allow you to really optimize, the use cases that subgraphs unlock. So that's essentially subgraphs. And they're very, very popular. They're definitely prominent in the space. And very easy. For example, if you're already familiar with building something on like the graph, it's fully the graph compatible, so you can migrate over really simply. Let's see, got a quick question. Some use cases for DeFi and apps. How can you use this for supply chain dApps? Yeah, so some use cases for DeFi and dApps. So basically, an example is Polymarket, right? All of their backend for their on-chain stuff, something we power. There's other example use cases where, let's say there's distribution of incentives and you want to track the APR, you want to track the wallets, you want to figure out, how much should go to each wallet. Incentive programs are often backed by this. If you want to create explorers, if you want to create dashboards, any kind of analytics, we'll often need this type of real-time data. So essentially anything that's going to rely on, looking at on-chain data, it's going to need to have some kind of indexing to at least have, reliable data, and then also to have efficient speeds. So a lot of very cool use cases for sure. And you mind expanding what you mean by how to use this for supply chain dApps? This is just a question in the chat for anybody listening in. Well, while he kind of gets back on that, a little more insights on what he means by supply chain dApps, I'm going to go back to the slides and talk a little bit about the next part of the demo, which is the evolution of indexing. So subgraphs were basically the very first way of really structuring on-chain data in an efficient way. You can almost think of subgraphs similarly to how Google, really changed the game. Rather than going and, looking through an entire catalog of websites and then picking what makes sense for you, Google really changed the game, right? You just search in your keyword, pops up with the URL, really, really optimize the search. So subgraphs and indexing, in a sense, are a similar kind of way of just really optimizing, finding what you're looking for and surfacing it in a more easily digestible, actionable way, right? So indexing was the first step, but there's definitely a lot of limitations because when you want to start combining data, whether it's from multiple different chains or off chain with on chain, maybe you want to do some more advanced searches, some more advanced analytics, you want to go real time where, as events are happening immediately, rather than calling an API, you want it to just immediately be, surfaced in your app. So there's definitely some limitations for indexing with subgraphs. And as scalability starts to become more important, right, as there's thousands of thousands, hundreds of thousands of users on an app, as chains start having incredibly high transactions per second, there's definitely ways where subgraphs shine. And then as scalability starts to come in, they might not always be as performant. So this is where Goldsky created a new solution called Mirror, where it's essentially a different way of approaching indexing. So rather than having an API endpoint that you pull data from and you query and then it's more of a pool, Mirror is basically real-time data streaming pipelines that push data. So in this graphic, you're seeing on the left here, basically data sources, right? So you can plug in on-chain data from, a specific data set that Goldsky has pre-made, whether it's a specific chain that we support, or it could be a subgraph that you've already deployed. You can actually use a subgraph as a data source for a Mirror pipeline. But essentially, the way that Mirror works is you pick a data source, you transform that data, you basically customize it to be exactly the kind of information you need, and then that's pushed into a database such as Postgres, ClickHouse, right, S3, essentially whatever database that you're currently using and whatever fits your needs best, that's where you can push that data to. And not only can you have historical data just all tracked in your database, but as data is happening real time at edge, you can have that pushed to your database. And so it's really, really really low latency, right? It's extremely fast, high reliability, and you're basically only limited as far as speed by the speed of how fast your database can query. So rather than having to make API calls, you just query your database, and it's incredibly fast, incredibly efficient. And when it comes to scalability, it's definitely the optimal solution when you're a large DApp that requires that kind of efficiency. So to kind of give more insights into what exactly Mirror is, so real-time streaming to a database. That's basically where, as events are happening on chain, whether it's a transfer, a mint, whatever is going on, that is directly ported into your database in real time as it's happening. And so you're in full control over the data, right? So full control over the storage of data. What that means is rather than having to reference an endpoint to pull that data, it's just stored into your database. So, once the on-chain events happen, you just have that record and you can do whatever you want with that data. It's in your own database in a table. So it really is a lot more flexible as far as what you can do with that, how you can manipulate the data, what you can, do with it, how you build out your app. So it's very, very flexible as far as that. Now, combining multi-chain and off-chain data, this is exceptionally helpful when, maybe you're a multi-chain app or you want to combine events from off the chain and have your app basically, combine that. So with a subgraph, you would have to deploy multiple subgraphs. Off-chain data, you would probably need to use some kind of other, subgraph wouldn't be able to give you off-chain data. So with Mirror, you can basically combine multiple different data sources into one stream. So it's a very, very simplified process and efficient way of kind of having this multi-chain and off-chain approach. So it really is designed for scalability and speed, right? With just high production, high transactions, high, just volume of activity in mind. That's really what Mirror is designed for. And historical data and edge streaming available. I'll show a little bit more what that means when I give the demo for how to create a pipeline, but you can choose whether you want to start from, the beginning of a chain, the beginning of a contract, or if you want to start from at edge and just, port over data as it's coming in. So you have that flexibility, and Mirror is just a really powerful tool. So now we're going to dive into, what exactly is Mirror. So back into the Goldsky web app, we're going to go to the pipelines page, and simple as over here, hit new pipeline. And as you can see, it's what we call Goldsky Flow. It's like this canvas where it's a really easy way to just visualize, how you're building out the pipeline. So the first step is you're going to pick your data source. And in this case, we're going with IOTA mainnet. And then you would basically choose the type of data sets you want, right? Whether it's transactions, move calls, events, epochs, checkpoints. In our docs, if you go to docs.goldsky.com, under supported networks, we have some more insights into, what these data sets mean. So if you take a look there, there's some descriptions to kind of, give you a deeper look under the hood of what each of these data sets move or mean. But for this specific example, I'm just going to use the transactions data set. And so this is what I mean about historical versus edge, right? You can start indexing at the beginning of the chain, or at a specific current point in time right now where you're indexing it moving forward. Now, this is specifically helpful if you're looking at a chain level. You really want to get some insights to the transactions happening on there. You really want to get that bird's eye view, whether it's historical or moving forward. This is a really great data set for that. To give some, just other perspective, if you were to hit other data sets, same kind of thing. You would just choose how you want to index from the beginning, from the end, right? So transactions, you've got where you're starting from, the chain. Now, custom SQL and external handler. These are two ways that you can transform these data streams that you've got flowing into your database, right? So once you've picked the data source, this is where you're going to connect the new block and do either custom SQL or HTTP handler. So for reference, HTTP handler, that's essentially, you would externally move that data and then after it's been modified however you want, bring it back. At least that's my understanding of that. So custom SQL is probably the more popular and, really easy way to do it. So basically this next block is you've got this transformation that you can make to this data that you're streaming, right? So when you're doing historical data, and you click into here, you might not necessarily want everything from the chain, right? Maybe you do. Maybe you want to have everything, but maybe you want to get custom about looking at a specific contract address, or you want to look at a specific person's wallet, or you want to look at specific, types of data, right? So you can get very, very custom about the SQL that you run so that you can have a subset of data that you're streaming rather than streaming the entire chain. So this is a really, really useful tool to just get more granular about what you're looking at. And it's also important too when you want to optimize the pipeline for costs as well. So one thing to keep in mind is, if you're going to be streaming an entire chain, that's probably going to cost more than if you're just streaming events for a specific contract from Edge, right? So that's just something to keep in mind. But generally, pipelines are going to be much more cost efficient than subgraphs. So you've got the data source, you've got the transform. Now the final step is you are going to connect your sink. Now the sink is a database. So when you create a new sink, you have all these different options for what you can select. So Postgres, ClosedCouse, DynamoDB, Elasticsearch. There's a lot of different options, and really it just depends on which one of these databases is most optimized for your specific use case, right? And where are you currently building? Where is your data already, right? So it really just depends. There isn't necessarily one answer that's better than another. It just really depends on your use case and what makes the most sense for you. You can even choose a webhook as a sink. So similar to how with Subgraphs have webhooks, you can actually create a webhook based on real-time data streaming. So once you select your sink, in this case, this is one that I've already got connected. You just basically now have the whole pipeline configured. And just to kind of show you what's happening in the back end of this visualizer, when you flip over here to YAML, this is the YAML file that you would be creating if you were to be using the CLI, right? So just like with Subgraphs, you can deploy either in the web app or in the CLI. Same thing with the pipeline. You can get honestly really, really complex and custom about the visualizing here. So you don't even need to use the CLI if this is a better workflow for you. So really, really simple. Final steps, of course, you're going to just want to name it. Make sure that you rename the project. And then when you're deploying, you want to choose the resource size. Honestly, most of the time, small is very, very powerful and can handle a lot. I would only suggest medium or large if you're going to be, ingesting entire chains, if you're going to be looking at pretty crazy high amount of data, it's very rare you'll ever need extra large or extra, extra large. But the system can handle it. So that's just something to keep in mind is it's a very powerful tool. But even small can handle a lot. Now, I'm not going to deploy it because then that would start putting data into the database and then going out into the database. Everyone's got their own different databases. Everyone's got their own way of looking at the data. So I'll just leave it here. But essentially, once you deploy it, it's going to immediately start putting the data into your database. And, you'll see that the rate at which a subgraph indexes on-chain data versus the rate at which a pipeline pushes data into the database, huge difference, right? I mean, you can basically in a matter of hours put an entire chain's data, if not even less, right? Maybe even 30 minutes. I don't remember exactly what the timing is. It's actually noted on our docs somewhere too. So you can take a look there and check it out. But, as far as how quickly data can move with a pipeline, it's incredibly faster just because of the way that it's built out than subgraphs. So definitely check out both. Highly recommend it. Play around with both, but yeah, it really just depends on your use case. There's definitely times when subgraphs make more sense. And there's a lot of times, maybe if not more often than not, where mirror pipelines are going to be cheaper, more efficient, faster, and just a better solution as you're scaling. So that about wraps up the demo. If you have any questions, definitely feel free to reach out. I got my Telegram and personal email up here. If you have really specific technical questions, I would suggest contacting support@goldsky.com. That's our tech services team, and they have a really efficient way of handling tickets. So any email you send out gets created a ticket, and then that gets handled. So would suggest that if you have very specific technical questions. But if you're a project, if you're a DApp or a protocol, and you want to connect with the Goldsky team, or if you want to talk about use cases, or you just, have some feedback on the presentation, or you have questions about Goldsky in general, feel free to reach out to me directly. But yeah, other than that, that completes the demo, and definitely would love to hear from you guys. So please do reach out, and yeah, we'll catch you guys on chain. But that's all for me today, Richard. Back to you.
No, thanks so much, Andrew. I mean, that was a lovely presentation, and certainly the UX was really really user friendly. So yeah, that was some great stuff. I don't think we have any questions currently, so I think we can probably leave it there. But I mean, that was great, and everyone knows exactly where to go next if they want to follow up. So yeah, I just want to say a big thank you, Andrew, for coming in and doing these workshops. It's been fantastic.
Yeah, of course. Happy to be here. Well, whoever's watching this recording, hope you enjoyed that. Definitely reach out. We'll connect. And if you're going to be at any conferences, maybe I'll see you in person. But yeah, reach out to us on X, reach out to us via email, Telegram. We'll talk soon, hopefully.
Yeah, that's great. And obviously from IOTA's standpoint, please come and join us on the IOTA Builders Discord. You see the link to that in the YouTube description. Yeah, thanks very much. Right, well, cheers everybody, and thank you